power. In this nugget, we'll take a look at power, and we'll start off with taking a look at some of the principles of electricity, such as understanding what volts and watts and things of this nature are. We'll also take a look at power supplies themselves, such as how to properly size a power supply so that you get the right power of a power supply. We'll take a look at surge suppressors, which can prevent damage to your system in the event of an electrical surge. We'll also take a look at UPSs, which is an uninterruptible power supply, and that will help to make sure that your computer stays up at least long enough to save documents if the power goes out. We'll look at laptop power as well. Unfortunately, the power cords for those are auto switching, so you don't have to change those to different voltages. You'll see that when we get there. And then also we'll take a look at an important topic here for the A+ exam as well, and that would be troubleshooting power. Now let's get started here talking about some of the main principles of electricity, which kind of really accompanies the main definitions of electricity too that you might see. And you may have seen all or some of these terms from time to time on various devices that you own and so forth, but many people don't have an understanding of what really all of these different things are specifically. And although I don't think you need to memorize these for the A+ exam, they will help you to get a general comprehension of what you do need to understand specifically as it relates to power supplies and things like UPSs. But otherwise, people might not be too familiar with these. Other than that, they might see a sign somewhere that says, "Do not enter 50,000 volts," and there's a lightning symbol sign there or something like that. Then people usually know not to go into whatever that doorway is or something like that. But otherwise, let's take a look at some of these terms, such as amps. Now, amps is, and I'm going to oversimplify some of these a little bit, but amps is really the measure of electricity, or the quantity of electricity that's involved. So, for example, if we were to think about electricity like water, and by the way, those two don't usually mix very well, then if we had a pump that said it was capable of pumping 5 gallons of water per minute, well, that would be the quantity of water that pump could produce in a minute. Well, with amps, we have a tendency to think of the quantity of electricity it's capable of. That's why, if you look at the breaker box or fuses at your house, most of those breakers or fuses probably say, 15 amps, maybe some of them say 20 amps. That's a measure of the amount of electricity that they're able to handle. And then there's also the volts. And volts really relates to the potential difference between charges on one side and another of an electrical system. That's why, if you take it in simple terms, like a AA battery, you see a little battery out here. What does it have? Well, it has a little plus sign up here and a little negative sign. That the plus sign is usually where the little knob sticks out up there at the top of it. Well, that would be a 1.5 volt battery, for example, and that would be the electrical difference between one side, the plus side, and the negative side. Okay, so that's just a simple example of how that is. If it's a car battery, then it's a 12 volt battery. That's the potential electrical difference, once again, between the two of them. And if you think of a measure of the electricity kind of in a wavelength kind of a fashion, then, let's say like this is a 1.5 volt battery. Well, this would be the plus side, and this might be the negative side. And that would be the difference between these two, might equal 1.5. And then if you take a look at something that's got higher volts, maybe you look at a car battery like I mentioned earlier, well, that'd be 12 volts. That would be a much greater difference between the top and the bottom of these. I don't know, it looks like I drew some kind of squid or a worm or something there, I don't know. Anyway, you get the idea there. It's really the potential, electrical potential between two portions of an electrical system. And then we have the term watts here as well, and watts really on its own is kind of a dead term. You don't really have any relevance with the word watts until you also understand what amps and volts are. So for example, what we have with this is really simple math. With amps, let's say I've got something that is capable of 5 amps, and I need to put electrical difference of how about 12 volts, okay? 12 volts. What we do to get to watts there, I could take these two numbers and determine how many watts that I need with that by multiplying 5 amps times 12 volts equals, what is that, 60? Yeah, 60 watts, okay? So all you have to do is to multiply these two to come up with the number of watts that you have, or the number of watts that you need. There's also something here called AC, or alternating current. Now, what's that about? Well, this is kind of a rough-hewn type of power. This is kind of a raw power, but it's also very efficient in terms of delivery of the power because, as you know, electricity actually travels from place to place. It travels, through a lightning bolt. It travels through, power lines. So if you have here, some kind of a power plant, out here in Phoenix we have a a nuclear power plant, a Palo Verde nuclear power plant, then it's generating all kinds of electricity out of it. Looks like I just made a hot loaf of bread there. But anyway, it's generating all this electricity, which comes across these power lines. Well, the power lines that get delivered to the homes and businesses are all alternating current. And the reason why is because it alternates back and forth between as it goes across this power line until it eventually reaches your wall outlet. Goes through your breaker box, of course, and all that. But it gets to your wall outlet here, and you've got, a couple of little bladed wall outlets. Now, by the time it gets here, it's still alternating current, but of course it's been treated a number of different ways. It's gone through transformers, it's gone through your breaker box. The power's been reduced to a point here where it's manageable and safe for electrical devices that you plug into it. And many larger appliances are just fine with alternating current. They don't need to really modify it other than to potentially reduce it for their own purposes. But I could plug, a vacuum cleaner in there. If you have a stove's probably electric. If it's an electric stove, it's probably on 220 power, and it could just run on an alternating current. It doesn't have to be treated in any special way. If you had a hair dryer, which, what would I know about hair dryers? I'm bald as a billiard ball. But anyway, my wife has a hair dryer. How about that? And that doesn't require any exotic power. So all those types of rough, high-powered appliances can plug directly into alternating current. But when it comes to direct current, then we have a problem here because we plug something into this, such as, I'm not going to use computers here. Let's talk about a cell phone. Okay, here's my little. I've got one of those, what do they call those things? One of those droids that's come out in recent times. And so it's got an LCD screen on here and, little buttons here that I can dial with and so on. And what we have with this is alternating current would be way too primitive, really, to deliver to this device. This is more of a low-power device, okay? And so I also need to have more refined power to this, and we do that with what we call direct current. So most of these types of devices will have some kind of a brick or some kind of an item. It's not just a simple power cord. It has to go through something in order to convert the alternating current to direct current. You probably see that also with laptops where they have the big power bricks that you plug in. So anyway, now these low power devices are something that's more electrically sensitive, has a lot of circuitry and so forth. That's going to be using direct current. Now let's go ahead and address power supplies and what you should do when it comes to ordering or replacing a power supply. One of the first things you need to address is the proper sizing. Now, many of the power supplies that come with consumer-level PCs right now are the bare minimum power supply that the consumer might need. So the manufacturer will say, hey, we are installing this computer with an optical drive, a single hard drive, a video card. So they might not think that the consumer is going to need very much. And that's probably going to be true right from the beginning. But if the user decides to add an additional optical drive, or if they decide to add some more hard drives, or even run some additional peripherals, they're going to probably start needing some additional power. So that's when that's going to need to be replaced. Oh, by the way, here's another thing. This is just a peeve of mine that you may have noticed as well. A lot of manufacturers that I've been working with lately, when I order computers from them, they will give me only the amount of connectors for the devices I have. So if I have a single optical drive and a single hard drive, I only get 2 Molex connectors for each one of those items, for example, or 2 serial ATA power connectors. And if I decide to add another hard drive, I have to get a Y splitter. If you're not familiar with a Y splitter, what happens with those is, if this is my power supply and out of the back of this is a connector for serial ATA power, for example. I'll just kind of put a block on that. If I've only got one, but I need 2, then you just get a Y splitter, and it will put 2 different additional connectors on there. The problem with that is you can start to daisy chain too many of those together, and it can generate heat on this line and can stress the power supply. So just got to be a little bit aware of that. But anyway, a lot of the manufacturers right now, or at least some of them, are only giving you the bare minimum that you need and maybe one additional one. Also, a lot of these cables will only reach exactly to where the, say the optical drive is. And if you wanted to move it to a different location or you wanted a little bit more room, you just really can't without putting some kind of an extension on there. You can get extenders on these similar to the way the Y is, except that it only has one. It just extends this. Or you could use a Y that, again, of course, also gives you a little bit of room. But it's a little bit frustrating right now because they're cutting pennies so tightly that they won't even give you additional connectors there. Anyway, for the sizing, let me get back to that. You have to understand how much each one of your devices will require. So if I have a couple of, let's say I have a couple of hard drives in the computer, and the hard drives normally are going to be the 12-watt hard drives. Also, your optical drives are going to be 12 watts as well, so that's a 12 watt plus 12 watt plus 12 watt. So that's what 36 watts just for drives and of various types right there. And then if you have something like a PCI Express video card, then those can start to be quite power hungry. In fact, if you use the Crossfire or the NVIDIA methods for using two of your video cards at the same time, a lot of those video cards require their own power connector. And those can be quite powerful as well, or require quite a lot of power as well. Generally speaking, they're going to require between 150 and 170 each. So you could have, another 300 watts just for PCI Express video. Okay, so now we're starting to talk about some real power here, aren't we? Then some of those PCI Express devices, at least theoretically, I haven't seen anything that will do this, but it is theoretically possible that some of them could require up to 528 watts just for the PCI Express video cards. So that's extremely large, especially when power supplies are usually 4, 6, maybe 800 watts on average. If you get higher powered ones, they can get over 1,000. So anyway, you just add stuff up. Now the other thing to think about there is, let's say you added everything up, and let's say that it turns out that maybe it adds up to, let's just say 300 watts total, over the drives and everything. So you think you only need 300 watts. Well, if you're like me, I'm kind of cheap. And I'll say, okay, I'll go to the electronics store and I'll buy the bare minimum cheapest 300 watt power supply that I can get. But that would be wrong because normally you don't want to max this out to the absolute total maximum that it's ever going to need. Generally speaking, what you'll do is you'll multiply the amount of watts that you think you need, multiply that by 0.6, because you don't want to use any more than 60% of the power. So if I can't, do math and think at the same time. So times 0.6, oops, wrong one, 300 times 0.6, let's try that. That would be 180, all right? So I would be able to only use about 180 watts safely out of a 300 watt power supply. But if I were to get, let's just kick this up higher. If I got an 800 watt power supply times 0.6, then that would mean that I could use a safe maximum of about 480 watts. So that would be within this spec. So I might need to get me, a 750 would probably be fine as well, but I might just get an 800 watt power supply. Now, another problem that could occur if you tried to max out your power supply and used, every last watt, there's actually a couple of them. One of them is when you do that, it makes that power supply run much hotter. And it's got some fans in it, usually just one or two. The better ones have two. But still, that's going to put a lot of heat out, and so that's not going to be good. Heat is always bad in computing. The other thing is, since you're already using the last available watt that you have, chances are that in some situations it may not even boot up properly. Because when you first turn on your computer, there's something called inrush power. That's not really an A+ exam item. It's usually more on the server plus. But when, for example, a hard drive spins up at first, it actually uses a little bit more power than it does in its rated specification. And it has to do that in order to get those drive platters spinning from 0 to whatever, 7,200 RPM or whatever. So it actually uses a little bit of extra power right there at the beginning. That's why a lot of servers actually have a technology where it will not spin up all of the hard drives at once, because a lot of times servers will have quite a few hard drives in them. But instead, it'll make them all take turns, and it'll spin up this drive and then that drive and so forth, so it doesn't have a big burden on the inrush power. So anyway, if you're using the maximum amount of wattage, the inrush power alone could prevent your system from booting up properly. And if you have a power sag of any kind, then it could also cause the computer to restart, because there's something called the power OK signal that goes to the motherboard. And it's able to identify how much current is going through. And if it gets a power sag, and if that power supply is already using all of its available power, and there's a slight power sag, then it could reset that power OK, and then it could reboot the computer, and that would be highly inconvenient. So also another thing you want to do is to get the best quality of power supply you can. You know, you always want to get the best of everything that you can, and I know that sometimes there's a budgetary requirement there, but certainly the power supply is one thing you probably don't want to skimp on. Now, one of the companies that I recommend, and I don't get any kind of kickbacks from them or anything. In fact, I doubt if they even know who I am. But it's PC Power and Cooling, and you can see the URL up the top there. And what you can see here is I've gone to one of their power supplies. This one's NVIDIA SLI ready, which means that I think this particular one actually has 2 PCI Express power connectors for your video cards. And that because a lot of times those video cards, like I said, will require extra power on their own. Another thing that you'll see there, actually, I think I got one open here. Yeah, there's a harness diagram. This is just kind of a logical diagram of how it's all spec'd out for the various components within this. Let me see if I can zoom in here, if it'll let me. Yeah, there we go. And you can see here that we've got a number of different types of connectors. Like these on the end here are serial ATA. I think if I move over, you can see them a little bit better. Serial ATA connectors. There's the motherboard power connectors, CPU power. There's PCI Express. Remember, I was telling you about that earlier. My particular PCI Express ones use 6 connectors, or 6 pins. So I've got 2 of those on mine. Anyway, what I'm trying to get to here specifically is if you look at the logical diagram, you'll see that these all come back to the same location. They're all on the same bus, if you will. This is actually called a rail when it comes to power supplies. Some cheaper power supplies have 2 or more rails, whereas a higher quality one like this one has a single rail. Now it seems like, wow, wouldn't more rails be better? Not necessarily, because there's no real way of identifying most of the time which one of these connectors goes to which rail. And you could, by some unhappy coincidence, connect all of your drives and everything to all of these connectors that actually go back to a single rail, thereby overpowering the capacity of that one rail. So maybe you only need, say, 300 watts, and it's a 600 watt power supply, but if you put everything on one rail, it's still going to get overwhelmed, even though the watts don't add up to being too much. Whereas if you have a single rail, then it's able to divide the power evenly across all of the various items there. So that's just the kind of thing that you can see. And with PC Power and Cooling, they give you a lot of those specifics. They tell you what each wire in each one of these connections is good for, and so forth. Now, if you happen to be standing at the computer store and you see 2, let's say, 750 watt power supplies, and you don't really know which one you should get, and they're both, seem to be equal in all other respects, equally priced, and that kind of thing, how do you know which one's better if you have no additional knowledge? Well, just as a general rule of thumb, it's not like a cantaloupe where you thump it and kind of listen for the sound that comes out of it. But it's similar to that. Actually, you just pick them both up, and you see whichever one's heavier. The heavier ones generally tend to have a higher quality components inside of them, and that's just a general rule of thumb. Not always true, but you can kind of use that as a general idea. Another thing you might want to consider for power supplies for yourself or for your customers is the noise that it makes. Now, it doesn't really bother me too much to have just normal power supply noise, but some people it's highly annoying. So you might need to get a quieter model like the one I just showed you from PC Power and Cooling. Now, the other thing you might see is if the fans are going bad inside the power supply, sometimes they'll make a racket. Anytime that starts to happen, just replace the power supply. Also, testing of a power supply. If you suspect that there's a problem, such as a computer that just spontaneously reboots sometimes. When this happens, it might be that the power supply has insufficient power to do all that the user needs. Maybe they're running a highly demanding application that is very disk-intensive, for example, and when those hard drives start to spin, which are pretty high voltage, then it could overwhelm the power supply and the power OK signal drops and the system reboots. Very inconvenient. So that really goes to sizing more than it does testing. So make sure that it's properly sized. But also, if the power supply is starting to go bad, then you can test the voltages coming out of the various pins on all the connectors using something like a digital multimeter. And then here's just a photograph that I took of my own digital multimeter. You can get these from Radio Shack or a lot of electronic stores. This one probably actually has more features than I really need. But the basic idea about these is that they're going to be pretty good for testing out PC computing and the power that you'll have there. One of the things you want to also make sure you do is, don't get your grandfather's multimeter, because, he may say, well, I've got one that has a little needle on it and it just kind of switches from left to right. Don't use those, because what those do is they actually kind of backfeed 9 volts into the circuit in order to do their testing, and that can be bad for electronic components that we use nowadays. So for computing purposes, don't use those, any of those that have the needle that swivel, from left to right, like a gas gauge looking thing. Use a digital one instead, because it usually only uses 1.5 volts, which is usually fine for most electrical components inside of a PC. Also, this one has, you notice it has an auto button there. Let me kind of zoom that in a little bit. Has an auto button there. That means that I don't have to select a range. You can manually select a range, but I don't have to manually do that. You can do it automatically, and the advantage of that is if I make a human error and I give it a range that's too low, but the testing a device that's very high voltage, it can potentially damage this device. Now, there's actually supposed to be a fuse in here. I haven't actually looked at it. There's also supposed to be a fuse in here to protect it against damage. You just have to replace the fuse if you overload it, but I'd rather just use the auto setting. There's also the data hold item. What that one does is if you are testing something and it kind of oscillates a lot, like the number kind of keeps going up and down, and it's kind of hard to read, you can just hit the data hold button and it should give you a read for what it is that you're trying to find there. So anyway, that's the basic idea for a digital multimeter. An example of how I might use that is maybe I would be testing the 12 volt Molex connector like I was right here. Now here I've just put one of the probes into the 12 volt, this yellow line here is 12 volts. This red one is 5 volts. And these two black lines right here are both ground. Anyway, since I put the red one in this yellow line, which is the 12 volts, once again, that's 5, then I grounded the other one, and then it gave me a reading for how many volts was coming off of this Molex connector. Now, by the way, you might be saying, well, James, why didn't you take that probe and put it on the case? Why didn't you just put it in one of these grounds? Well, a couple of reasons. Number one, if I accidentally touch metal contact between the two of these, I can short it out, cause an electrical problem there. Although it's unlikely, because you can see that there's kind of this round portion of these leads that prevents them from bumping into each other. But just as a precaution, any ground would do. So that's one reason why I chose that one. And then the digital readout would read out how many volts I had. And this one was like 12.3 or something like that. It doesn't have to be exactly 12. Usually, if you're within 10% plus or minus, then you're normally going to be just fine. And then another thing I've actually started to use quite a lot more lately is a power supply tester. This actually gives me more immediate results a lot of times than a digital multimeter will, although this is a high degree of accuracy as well. But let me show you an example of that. If I go to this one right here, this is one I think I showed you early on in our series here. And what you see this is that you can have a number of different kinds of connections you plug into this, like a Molex connector here, for the kind of connection I would put onto my hard drives, like IDE drives or optical drives, for example. Then we would have here a Berg connector for like my floppy drives. If I flip this around, I think I have some other images of this, then we can plug in our 24 or 20 pin power connector that goes to the motherboard. Okay, so that's just another connection that we can make there. And then we also have, on the opposite end of that, we can have our CPU connectors here, which can be 4 or 8 pins, as you can see right here, or PCI Express connectors, which are 6 or 8 pins. My particular ones are 6 pins. Anyway, what happens with these is, if I have the power supply on and I have the motherboard connector connected to the motherboard, then I can connect these on the side, like these CPU or the PCI Express ones. I have to have the power supply running in order to test these. And then in the middle here, actually over here, in this section right here, each one of these little lights will light up if it's getting good power to each one of those voltages. Plus 12 volts, 3 volts, 5 volts, and so forth. And then the same thing would happen with the Molex connector that I also showed you, and let's see, that would be on this end of it. Remember? The Molex connector. That would also show me whether it was getting its 5 volts and its 12 volts. It doesn't use 3.3 volts. So that would be an example of how I could use this power supply tester. And then I actually used it a little while back here, and I thought I'd take a picture of it, because I wasn't quite sure about a power supply. You see, I was delivering this computer to a customer, and they just wanted it to be built cheaply out of parts that I already had. Well, I haven't used the power supply for a long time, so I thought I'd better test it out. And what you can see I've done here is I put the CPU connector into one end, that we can see over here. And then on the other end of this, let me zoom out a little bit so I can use my little pen. I put in the motherboard connector over here on this end. And then what happens with this is there's actually a button here that's underneath my thumb. I have to push that on, and the reason why is that normally the power supply does not come on unless it gets a power OK, or unless it gets a signal from the motherboard, because there's a switch. You know, on the front of your computer, there's a switch that's connected to a block on the motherboard. Well, with this being disconnected from the motherboard, there's no way for it to communicate with that. So I have to push down the button in order to turn on the power supply. The power supply only runs while I'm holding down that button, and then you can get the readout in here. You know, it says that I've got 5 volts is fine. I've got my 3.3 volts. I got my 12 volts. So it looks like everything is well within spec with this particular power supply. Let's also talk about the switching that occurs on a power supply as well. There's switching or auto switching. It just depends on the motherboard, or rather the power supply manufacturer. What I'm talking about there is, in the US, we use 120 volts that come into our household current. Sometimes you might have heard 110 or 115. There is a little bit of wiggle room there, and it is reduced sometimes because, for example, if there's a long cable run, then that will also dip a little bit, but still within acceptable parameters. So any of those numbers is fine: 110, 115, 120. And then what we'll see here is on the back of your power supply, this is kind of highly magnified, but there's a little switch here, and you can see in this case it says 115. But if I go to another country that uses different current, normally it's going to be double what we have in the US, so I'd flip that up, and it would then be able to accept like 220 power instead, or up to 240, for example. But just make sure that if you do take your computer to another country, that you do that. I don't know why this is a big emphasis, because most people don't just haul their computers off somewhere else. Usually they'll take a laptop, and laptops normally have power supplies that auto switch this, so you don't have to worry about it. Some of the power supplies that do come in your computers will also now have auto switching as well, so you don't have to flip this switch. It'll just automatically detect how much voltage is on the outlet that it's plugged into and switch internally accordingly. Now, by way of review, let's also take a look at a power supply installed in the case. We saw this a little bit earlier in a previous nugget, but remember that it's got the 4 screws around the outside here that will attach it to the case, and that's how it appears from the outside. Here's the switching portion that I told you about earlier, where you can switch from 115 to a higher voltage if you're in a different country. Make sure that this cable here is pushed all the way in. Sometimes those do work their way loose, and the user will complain that they can't turn their computer on. And also that this is in the on position, which is pushed down where the white line section of that particular switch is. And then on the inside of the computer case, you'll see something like this. This is very often going to rest on rails. Normally this will appear at the top of a tower case, and you'll see the cables coming out of this as well back here, which can be quite a mess, by the way. That can be quite a tangled mess. However, there are some newer power supplies, which I'll show you photographs of here in a moment, that clean that up a little bit using a number of different methods. Let's address also surge suppressors. Now, these are going to be very important. They can also be considered synonymous for our purposes with a surge protector, which I think is probably what most people call these. Although there's actually a bit of a difference, some technical differences, but for A+ exams, we can consider them the same. What these are going to do, though, is they're going to protect you against unexpected surges in electricity, which could blast through the power supply and, number one, blow out the power supply, or number two, could also pass through the power supply onto wherever you have power connected, the motherboard, your drives, whatever, and it could fry those items as well. So it's very important to have a surge suppressor, and these are going to normally be rated on joule ratings. And if you go look at the good ones, then they'll say it's rated to 500 joules or 1,000 joules or something like this. And you might wonder what's a joule? And by the way, didn't I misspell it? Actually, it's named after somebody that's named Joule, James Prescott Joule, and he came up with this formula right here to calculate what a joule is. Okay, I have no idea what that actually means, but if you can get back with me and let me know, then I'd appreciate it. No, actually what that is it's just a measure of the work that's required to continuously produce a watt of power for 1 second. That's all that really is. And so they're calculated on that basis. All right. Now, as we take a look and work with these, though, you'll see that there's a number of different suppression methods that these devices use to prevent power surges from damaging your equipment. One of those would be a metal oxide varistor. Now, this is something that is just a shunt, really, so that if the voltage exceeds a certain level, then it will intervene and it will send any additional electricity to ground. although it can only handle kind of normal utility surges that might come from a utility company. It is not capable of handling lightning strikes. A lightning strike will blow right through one of those things. But generally, they're designed to accept voltages up to about 6,000 volts, and they were supposed to divert anything above 200 volts to ground. The thing with these is, over time, and if there's been pretty kind of dirty power that goes on, where I know that sounds like, you know, a dirty politician or something, but if it's the kind of power that you're in a location where you get a lot of surges, it can eventually start to wear on these, and they don't have the same lifetime or reliability that they had when these devices were brand new. So they have some varying degrees of quality over the passage of time. There's also breakers that you could use. These, I don't mean the breakers that appear in your breaker box. There's breakers that sometimes will appear on the surge suppressors, so that if too much power passes through them, it will just trip a breaker in that power strip surge suppressor. And by the way, I should also point out, all power strips are not surge suppressors. A surge suppressor could be a power strip, and they usually are. They usually have like 6 outlets on them and stuff like that. But if you just buy, you know, at my electronics store, we get surge suppressors for a power strips. See, even now I'm getting it mixed up. Power strips for $1.99 for a 6-outlet power strip. There's no surge suppression in them whatsoever. I'm not even sure why I buy them. I think it's just because they're such a bargain, I can't resist. Also be aware that these surge suppressors, when they trip or any of these methods are used to prevent a power surge, your computer's gonna likely shut off, because it's not going to receive any power, because all power is cut off through one of these methods. So you could still lose data, your operating system could still get corrupt, but at least you didn't fry a motherboard, okay? There's other methods that I'll show you later on that might help alleviate that situation, though. Also, there's a fuse, which would just be the normal kind of fuse that you might see, a little glass-looking fuse. And when it receives a certain amount of electricity that surges through it, it actually melts the fuse, and then, therefore, electricity can no longer be conducted through it, and power stops. There's also something that's kind of sophisticated here, a gas discharge arrestor. I find this one kind of interesting. There's an inert gas as a conductor between the two lines in the surge suppressor. And it's normally not going to do anything, but if the electrical power exceeds a certain threshold, it actually ionizes that gas, making it a conductor. And then at that point, it will conduct electricity away from the normal flow of electricity and on into ground. Now, some of the surge suppressors also may provide some limited line conditioning. They'll usually advertise that they do that. If so, remember that you have voltage going through, and it kind of appears, you know, like this, higher and lower electrical potential. Well, as it's going through, it may come up to not really a big surge, but a little bit higher than usual. This is sometimes what we call dirty power, where it's not reliably on the same electrical potentials. Well, line conditioning kind of tops that off and gives you a little bit cleaner power, and you'll see that term used a lot, clean power. So some surge suppressors will do that. You're more likely to see that with a UPS, however. Now, also by way of review, let's just revisit again that you can have a motherboard that needs a 20-pin power connector, and that would be from this point right here, over to this point over here. That's 20 pins total. If you take a look at this one, though, it's too many, and then sometimes you'll run into this, because the power supply that you're replacing may be on an older computer where it has 20 pins for the motherboard, but the only connector that you have is this one. It's okay to go ahead and use this. Very often, this will have room where these actually may hang over the side, these extra 4 pins, or as in the case of this particular one, they actually clip off like this, so you can just detach it as necessary. Just be aware of that. But most good power supplies will have this option where it can be detached like that. And then also, I don't really have a photograph for this because it's kind of an oddball, but you may have particular computers that were purchased from manufacturers that have their own proprietary power supply. They're not shaped the way an ATX power supply is. They're different dimensions. They won't, if you buy an ATX power supply, it won't fit in the same case. This may be the case especially with small form factor computers. And if that's the case, you may have to get a replacement exactly from that manufacturer, and you might not be able to get third-party ones. So just be aware of those proprietary shaped power supplies. Also, this is not really an oddball so much, but Dell, for example, does use very often a strangely shaped power supply that you would have to get from Dell, although there are manufacturers out there that will also make for you a power supply that is in, the Dell form factor. And then here's one of the power supplies I was talking about earlier. Remember I said there's a big mess of cables that comes out of the back of the power supply? Some of those, like you see right here, are unavoidable. That's just going to be the way it is. But some of these, like this newer power supply, are pretty cool. What you do with this is you just actually plug in only the cables that you actually need. So if I've only got, maybe these are for hard drives. If I've only got 4 hard drives that I need, then I just won't plug in this bottom row, and I'll just keep those in a desk drawer for when I need them later on. That's just one kind of these that you see, and it has a little clip. I don't think I can push it any further because I lose resolution. It has a little clip on there that holds it into place. There's another one that I like. I think I like this kind of design better. These are twist locks, where you'll just push them in and twist lock these particular items. These kinds of designs, this one and the clip-on ones that I showed you a moment ago, are called modular power supplies. You can just add and remove what you need as you need it. Let's address also something called a UPS, or an uninterruptible power supply. Okay, usually we just call them UPSs though. What this does is it allows my computer to continue to operate even if the power goes out, and most of them will also provide a lot of line conditioning for us as well to give us good clean power. The way this might work is, I might have my wall outlet here, okay, and a couple of blades there, wall outlet, another outlet here, and normally we would just plug our computer into that, or into a surge suppressor, and then plug our computer into that. Okay, so we're really getting direct power, more or less, from our wall outlet. With an uninterruptible power supply, however, that would prevent us from having a loss of productivity in case the power went out. You see, if we're just plugged into a wall outlet and power goes out, of course, you're out of luck. The computer just shuts off. However, with a UPS, what happens is we plug our UPS into that instead, and I'll just put a picture up here like this. Maybe this is like a big battery, and that's what it really is. It does a lot of things, but one of its main function is it's really just a big battery, and then we'll also plug into that then our actual computer. And then if what happens is, if this power here were to fail, our utility power were to fail, then our computer would still run off of this battery, this UPS, our uninterruptible power supply. Now, there's a couple of different forms of this as well. Some of the older ones might be a standby power supply or an offline power supply. These are not preferred, but they may still be some out there. What happens with those is it really doesn't kick in the battery until it detects that the power has gone down. What's really happening is there's normal electrical current flowing through it to the computer, but the battery itself is not charging or is not providing power to the computer. And then in just a mere moments, it will detect if there's an interruption in the power from the wall outlet, and if that happens, then it will immediately kick in the battery. Now, there is some of a little bit of a latency involved in that which could occur. This may cause memory errors, or it may cause a reboot anyway, especially if the SPS is not a well-designed one. So, generally speaking, I prefer the line interactive, and I think you're going to find that most of those these days are line interactive. This means that the computer is always running off the battery. In fact, that's the computer I'm using right now is running off of a battery on a line interactive UPS. If the power then goes out, there's no switching over that takes place. The computer was running off the battery in the first place, and it's still running off the battery. All that's happening that's different is that the battery is no longer being charged by the wall outlet. Other things that the UPS will do for you is to provide automatic voltage regulation, or AVR. This will protect you against things like sags and brownouts. And you can understand that because since this computer is being powered by a battery, then if this power goes out, or if it sags, or if it has a brownout, then it really doesn't affect the current going from the battery to the computer here. Okay, so it really has no effect whatsoever in that respect. Also, for surges and spikes, has a lot of the same functionality that one of the better surge suppressors would have as well, because that's also very often built into these UPS devices. So it's going to give you nice, clean power in most instances. One thing I would point out too with this, let me just oops, that wasn't messy. Let me just show you an example. If this is the back of my UPS, you're going to usually see a number of different plugins, also known as outlets. Plugins. Yeah, they freshen up the room with springtime fragrances. Anyway, these plugins that go in back here, and what I want to do with this is to show you that some of them have different purposes or different power sources than others. So, for example, it might be that these bottom three are really the same as just plugging into the wall outlet. So these just have pass-through power, so that it would just go through the UPS and on into this electrical power over here. It doesn't really receive any power from the battery at all. It's just pretty much the same as using an extension cord from the wall outlet through the UPS to the computer if I were to use one of these. And it'll be marked on the back of these where you plug things in. And then the other ones would be protected, and they'll often say protected. And these would be the battery ones, which would be using this method that I showed you earlier. There's also normally going to be a serial cable or a USB cable that goes from the UPS into the computer, and the purpose of that is to interact with software. Windows Server may include the capability to do this on its own, but normally we use the proprietary software that comes from the manufacturer, whether it's Triplight or American Power Conversion, APC, that's who I normally use. And they have software called TroubleShoot software, such that when the power does go off, a signal is sent from the UPS to this computer over the USB cable, and it interacts with the software that says, hey, power's gone out. The software also can identify how many minutes of uptime I'm good for on the battery here. So let's say that it says I've got 20 minutes. Well, I can configure this software so that it says, hey, after 5 minutes, go ahead and save my documents. And then after 10 minutes, I'm running out of room here, I want you to go ahead and shut down gracefully, okay? Because I would not want to get in the position where I've depleted the 20 minutes of battery and then the power to just turn off to the computer, losing all of my documents and potentially corrupting the operating system. When it comes to making plans for purchasing a UPS, you have several considerations that you have to take into account. First of all, you do not want something that's undersized and underpowered. Kind of like what I was told when I tried out for the high school basketball team. No, what you want is something that's going to be able to properly cover your needs. So you need to size it in a similar way to what you do for selecting a power supply in the first place. Remember, you only want to use a maximum of about 60% of the available wattage of your power supply, and it's somewhat of a sliding figure. Depends on what your budget is and how and so forth. But you certainly do not want to get a UPS that is going to be rated at exactly the same as your power supply. So if my power supply is at 550 watts, and I've got a monitor that maybe needs 50 watts, then I got a total need of about 600 watts, and I have to give myself several minutes of uptime. So if I get a UPS that's exactly 600 watts, I'm probably only going to be up for a few seconds before the battery gets depleted, maybe a couple minutes. So what we'll need to do instead is to get an oversized, at least compared to our total watts that we need, an oversized UPS. Generally speaking, I've been using 1200 watt ones, and they seem to give me several minutes of uptime that gives the software time to save and close my documents, as well as shut the machine down gracefully. Or if I'm at the machine when all this happens, then I can do it myself, and it seems to be pretty good. Another thing you want to make sure of is the only plug in the things that you actually really need during this time. I mean, you normally don't plug in a printer, because anything you can print now, you can print when the power comes back on. What you really want is to only plug in those things into the UPS, at least into those that are protected plugins, things like your PC and your monitor. You got to be able to see what you're doing, so of course you need your monitor plugged in. But you do not want to plug in additional items that you don't really need right now, such as the laser printer especially. Laser printers are very electrically noisy, and if someone sends a print job through it, it'll pull a huge amount of power off of that UPS. So you don't want that. Now, if you absolutely had to, for whatever reason, plug in some kind of a printer, you could possibly plug in an inkjet printer, because they don't draw as much power and they're not as electrically noisy as a laser, but I would still advise against that as well. You just really don't normally need it. And then don't plug in one of those little small office fridges that, have cold beverages in them and stuff like that. I know cold beverages are important to some of your users, and they've got to have a cold Coke right near them, but don't let them plug those things in, at least not into the protected outlets. They can use some of the other outlets if they want, and of course the power will come back on and the fridge will get cold again. Also, don't plug in things like a portable heater. My wife is constantly cold. Even in the middle of the summer, she will say she's cold, and that's here in Phoenix where it can get to 115, 120 degrees. Year-round, we have a portable heater plugged in. Of course, we don't plug it into the UPS. If the power goes out, she'll just have to be cold for a little while. But as you can imagine, those portable heaters draw an immense amount of electricity, and so you wouldn't want that plugged into your UPS either. Otherwise, the few minutes that you'll get out of this, I think I can usually get about 15 minutes out of my 1200 watt one, that'll probably drain down to just a couple of minutes if it can even handle the additional power that's required from something like one of these appliances. You wouldn't plug, a hair dryer into it or something like that either. And all of these things I'm telling you about, as far as what you plug in and what you don't plug in this list, I would be very well aware of this type of thing for A+, because it's definitely within the line of the exam objectives. Now, although I have a whole section on laptops alone, I do want to cover laptop power here since we're kind of on the subject for that. And I want to identify that you will have an AC power adapter, of course, for your laptop. These are usually auto switching, so you don't have to worry about those. And in fact, if you look on them, it'll usually say somewhere around 100, 110 volts to 240 volts input. And then it'll say whatever the output is, which is usually somewhere between 18 and 19 volts, somewhere in that range. So those are going to switch themselves, and they're a little bit inconvenient. You'll see that they have a plug, that plugs into a wall outlet, and then they'll have a little cable, a cord right there, and then they'll have this brick. That's where the auto switching takes place. That's where the transformer and rectifier are. And then they'll have another section of cable and a little plug on the end with a little hollow out center where the pin from the laptop goes in. One of my peeves with this is that this section right here, this brick section, all that it does used to be inside of the laptop on some of the older laptops, like some of the early Toshibas. But then their laptops weighed more, and so it didn't look as good on marketing materials, so that they then had to move this out onto the cord like we see it here. So I really wish we had simpler cords and a little slightly heavier laptops. You got to carry the whole thing anyway. For troubleshooting a laptop, oops, I almost forgot one section. Let me go back up here. For cells. For cells on a laptop, there's going to be 6 cells or 9 cells or somewhere in these ranges. Many laptops you can order with one or the other. And the only real difference there, of course, is that the more cells it has, number one, the heavier it is. Number two, the longer the charge is going to last. So if you're on a coast-to-coast or a long flight or something like this, then you might want to use the additional cells. Although you can also buy the kind of flat batteries that you can buy from different companies here that allows you to use them as external auxiliary batteries if you have pretty long trips to make. Now, for troubleshooting laptop power, one of the key things to look for, and this actually, a lot of this applies to laptops and desktops as well, is you want to verify the AC-DC power. For the alternating current where it plugs in here, you will very often on this brick section, you might see a little light that appears here somewhere. And let me just give it a little bit of a color flare here. It might be some kind of a light that flashes on. That's supposed to be yellow, or anyway, that flashes on that identifies that you are receiving power from this. On the DC side of things, you might need to use a digital multimeter in order to test this little plug on the end. Here, I got a picture I'll show you. And then by way of example, here you can see I took the leads from my digital multimeter. I put the black one on the outside casing. I put the red one on the inside where the pin will connect from the laptop. And when I did that, I got this reading on my digital multimeter. It's 18.5 volts is the rated output for that direct current. 18.76 is, of course, well within spec because we're at least 10% within that spec. Then other things you'll want to do as well is to verify the connections. Sometimes, for example, this cable right here, this cord, comes out of this little brick. This can be removed. I guess it makes it easier to transport and stuff like that. It's not molded into the brick, so then sometimes that might come loose. It might come loose also on this end. I've frequently found that does come loose because it's a small connector. Another thing you will sometimes see is that this makes it a very fragile break point on the laptop. Laptops get moved around a lot, and they're in planes, they're busy places, and a lot of times when that's plugged into the back of the laptop, someone can accidentally bump it or not realize it's there, or set the laptop down and smash it against something. So that little input where it goes into the laptop a lot of times takes some abuse, and it very often needs to get repaired. In fact, my daughter and my son-in-law's laptop computers both have that problem. I don't know if they've bumped them or whatever, but both of their input power is barely hanging on. I probably need to fix those. So verify those connections. That's true not just of laptops, but of all different kinds of computers, servers, desktops, whatever. Oh, also when it comes to that as well, a lot of times you'll find that right where this cable here, this cord connects to the little brick item right there, sometimes that gets frayed. I mean, these things get twisted up and tangled and turned into knots and really pretty abused, these little power cords. So sometimes that'll start to get frayed, and you got to be careful of that because that could, number one, could be potentially dangerous. But also, if it does start to happen as a temporary fix, I will usually use not even electrical tape, but I'll usually use gaffer's tape because it sticks better, but it's not as messy as duct tape. But that's a short-term solution. You need to buy another one if that happens and starts to get frayed. And another thing to consider is you can usually get a generic for much cheaper than the original manufacturer brand. You can look on eBay, Amazon, lots of different sources. Verify the power saving settings as well. And in order to do that, if you were on like a Windows Vista machine, for example, then you could go into Control Panel here, and I'll just take you there, then we'll move along. We would go to Hardware and Sound, and then we would go down to, where's it? Oh, I'm right over it. The power options. Okay, so we would change our power options here, and you got to click through a bunch of different stuff to get here. Then notice that we are on the high performance settings. I could change the plan settings and change it to something else, but look, I can't really do anything. Notice the little shield icon on Windows Vista machines. This is an indicator that you need to be an administrator to make those changes. And since I am, I could click on that and proceed. If I'm not logged on as an administrator, I have to know the credentials to type in, which a prompt will appear to allow me to type in. So I would just click this little item. I would have to consent for permission to do that, and then I would tell it when to turn off the display and so forth. You see, sometimes a user might think that the computer's turned off or it has some kind of a problem because they're not being able to see anything. Well, if they haven't been using it for 10 minutes and they walk away and they come back a few minutes later, that might be the reason why. So that's one of the things to look at there. There's also additional power settings that you can configure, and you can see there's various different schemes that are available for you. If a user gets carried away with this and they mess things up so much that they're not really even sure where they started from, you can restore the plan defaults, which again, of course, requires administrator privileges. Much of the settings for performance, though, relate to the hard disk and the display. So here we can turn off the hard disk after a certain number of minutes as well. Otherwise, it keeps spinning and draining battery power. That's not normally necessary for a laptop. So if you're not actually using the laptop, then it will spin down and quit consuming that power. And like I said, the other one that really uses the most power is usually the display item here. So you can change the setting from never to some certain number of minutes if you like there as well. And that's the main idea for what you need to look at for the power plan settings for a laptop. And then you're also going to want to check for a faulty charging circuit potentially. If everything else is fine, the power cord's fine, you're getting a little light. Sometimes they have a little light on here that lights up to identify that the power is flowing through it and so on. It's not frayed here. If everything's fine and you tested this with your digital multimeter, but the laptop still doesn't charge, that could indicate two things. Number one, a faulty charging circuit. I would know about this for exam purposes because it's well within our exam objectives. But on a practical sense, another thing that you might be running into is that sometimes these batteries just go bad. It's not that they can't hold a charge anymore. Sometimes they won't even begin to charge anymore if the battery has just gone bad on that battery. Also check for a loose or broken DC jack. That's what I was telling you about earlier, like with my son-in-law and my daughter. Theirs is almost broken loose. So check for those items as well. And then let's conclude with some troubleshooting. And then again, I have a whole section on troubleshooting that we'll take a look at as well, but there's so much that's specific to power that I wanted to address this now. First of all, always check the physical. That's kind of what I addressed when I talked about the laptop. Checking the cord, making sure everything's plugged in, that something's not frayed. All that sort of thing. And this would apply both to laptops and desktop computers. One of the other physical things to check for is, again, that power switch on the power supply itself, that little toggle switch. Make sure that that's switched over. Make sure that if the computer has been moved from overseas, that it still doesn't listed as 220 or 240 when it should be listed as 100 or 110, for example, or 115. Again, those numbers change depending on the manufacturer. Also check for excessive heat. If a user is complaining that, boy, that the server, or excuse me, the desktop computer that's underneath their desk, it seems to be generating a lot more heat than it used to. We really want to check that. It could be other things such as the case fans. One of those may have failed or become unplugged, and you need to replace those potentially. Or it could be the fans inside of the power supply. If one of those has failed, then you could have a problem. Also, if the fans are working, but you're still getting a lot of heat off of that power supply, it's probably starting to fail, and I would just replace it now. Or it could be that it's just having too many demands put on it. It's not sized properly, and you need to get a more powerful one for that user's desktop. Now, if one of the fans starts to go out on a power supply, don't ever try to fix it. In fact, never ever open up a power supply. I don't think I listed that on this whiteboard anywhere, but do not open. And the reason why that's a big emphasis, and you'll see this on, I think, as an A+ issue, is that there are capacitors inside of that power supply, so that even if you were to use your Torx screwdrivers, or especially screwdrivers to open it, which you'd have to use, the capacitors inside of there store an enormous amount of electricity, more than you would actually get out of the wall jack itself. So you could potentially damage or hurt yourself by accidentally touching some of those capacitors in there. So do not ever open the power supply. It's a FRU or a FRU. It's a field replaceable unit. Just replace the thing entirely. Don't replace the fans. Also, it may just have insufficient power. Once again, that would be a symbol of excessive heat. Or if the user opens up a particularly demanding application which spins up the hard drives and they get quite busy, and then suddenly the machine reboots, well, they probably don't have enough power in the power supply, so they got a sag that the system's not able to handle. Also, a bad power supply. What are the symptoms of that? Well, again, reboots, because if it's not delivering enough power, for example, to the memory banks, then they'll start to drop data, and when they start to get errors, they very often will just reboot or they'll blue screen. So that's a problem. Also, certain devices might stop. So you have two optical drives on the system, but one of them won't open anymore, or sometimes it will. Well, that again might be because there's insufficient power. Here's another thing, and this might sound almost like a joke, but when you touch the case, if you get an electric shock, now, I'm not just talking about static shock that happens sometimes. I mean, you actually get an electrical current that passes through you. You know, stands your hair on end. If I had any hair, maybe it would stand on end. Well, this again is a potential symptom that the power supply has gone bad, although in my view, it's probably more likely that there's something that's touching the case that should not be. It could be that a power cable has gotten pinched when you close the door. It might got pinched on there, and so every time you touch the case, it sends a surge. This could also adversely affect various ports as well. So if current is traveling through that case, it could affect those ports like USB ports and FireWire as well. Look for signs of surge damage, which may have occurred. This will often occur as discoloration, especially around certain chips on the motherboard, for example. You might see some scoring or some discoloration. Also, check for strange, those electrical kind of odors. Even on a healthy power supply, it's going to smell kind of electrical smelling. You know what that smells like. But if it's an unusually strong odor, then it may have gotten overheated at some time and needs to be replaced, or it may have started to smoke, and in that case, of course, again, as well, you need to certainly replace it. So anyway, all of these things are probably going to be very important for A+ exam objectives, so I would definitely be aware of these items. In this nugget, we took a look at power. We looked at some of the principles of electricity, such as volts, amps, and watts, alternating current, direct current. We took a look at power supplies. Remember, you don't want to use any more than 60% of the rated wattage for your power supply, and you might need to get a bigger sized one if that's not sufficient power. We also took a look at surge suppressors, which are not the same as power strips. Power strips may have no electrical protection whatsoever in them, whereas a surge suppressor uses something like a metal oxide varistor to prevent surges from damaging computer equipment. We took a look at UPSs as well. These are what's going to allow continued power to be provided to your computer in the event of a power outage. We looked at laptop power and how to test the laptop connection so that you can make sure that it's got the power going through it as necessary, as well as many other troubleshooting topics that we looked at that may apply to both laptops and desktops, by the way. And hopefully using this, you'll be able to come up with a whole plan for power for your solutions. Well, I hope this has been informative for you, and I'd like to thank you for viewing. Let's also take a look at this fine artwork that I've created here. I have to say, this is probably my crowning achievement of artwork, drawn by hand. I know you can't tell. Probably looks like a sophisticated Visio program or something created all this, but no, this was all hand-drawn by me. Some of you were thinking, are you sure you didn't have a grade schooler do this? Anyway, this is kind of illustrate for you the flow of electricity. Now, again, you don't need to memorize this for the A+ exam, but it just helps you conceptually, I think. If you take a look at something like a pond here. Maybe we have a pond with water here in the pond, and we have a pipe going up here with a pump up at the top that pulls water out. Okay, I know, pumps usually push water, but anyway, we'll say that this pump pulls water out, and it pushes it down to this water wheel. Looks more like a ceiling fan, but that's okay. It goes down to this water wheel, which turns this water wheel in a certain direction. Okay, and when the water wheel turns, then it's able to do whatever it needs to do. You know, grind some grain, or just look pretty, or do something. You know, generate electricity, something like this. So that's kind of the effectiveness of having the circuit go through. And then when the water falls down from here, it goes back to the pond, and then it eventually goes back through this whole cycle. So if you take a look at this, the high point for all of that would be right up here. Okay, when the water gets to its highest point. The low would be down here when the water gets to its lowest point in the pond. It's similar with things like voltage, because remember, voltage has a high point and a low point as well, and it's the electrical potential that is measured there. If you take a look at electricity and the way it flows, that's very similar to what we might see here. So here I've got, you know, a battery. I know it just looks like a AA battery powering a light bulb. Imagine that. Anyway, a AA battery, and it also has a high and a low point. Okay, it has the flow of electricity going through over here to this light bulb over here. And it returns that back over here to the low point, and then it just goes through this whole cycle. Now, by the way, you might look at this and say, James, I think you got these mixed up, because low is at the top and high is at the bottom. You know, I would expect the high to be next to the positive and the low to be next to the negative. Well, positive and negative don't really mean anything in terms of, you know, altitude or better or worse or anything like that. We used to think that the high actually was the positive. It turns out that the flow of electricity they found in recent years, the high point actually is the negative side of this. So anyway, that's why I've got it marked that way. Not that that's terribly important. And then when we have something like a switch that would turn off the light, you know, if we have a light switch on the wall, what that does is it breaks the circuit so that there's no longer a continuous flow here, and that's when the lights go out. Okay, so that's the idea for how electricity flows.